Welcome students. I just come up with a question from center of gravity. Locate the center of gravity of a bullet 1 centimeter diameter with a cone and the front and a hemisphere cut from the back as shown in figure. Assume the material to be homogeneous. So here it is been said all the materials combined together and the bullet is just a homogeneous. Okay, so in with respect to the volume, we just going to take the centroid formulas. Okay, let it be. First, get into the solution part. We know to find the center of gravity x bar and y bar. We just going to find it out. And solution, already it's been given in the question in a proper manner. The coordinates x y and all the components have been just divided, and it is a three component. One is I can say it's a solid. Okay, it's a solid, and here at the bottom of it there is a hemisphere cut, and the top of it it's a cone. Okay, so just we can try to get the self center of gravity of each and every component individually. So first start with the first one. So here the first one is a cylinder. So in the cylinder, just position it. So here this is how the cylinder is, right? So this is how the cylinder is. Okay, consider it is a cylinder. So here the height of the cylinder, which is given 2.5 centimeter. Okay, and bottom which is 1 centimeter it is given. Now x bar, x1, we can find out the x1. So here the CG, here that means x bar or x1 which is here, and y1 is this distance. So just it is beginning from the bottom OX, and in the y axis it is beginning from OY, I mean the cylinder. So just put the self-centroid formula, CG formula directly for the cylinder x1, which is nothing but here it is a diameter, so which is d divided by 2. Here it is given the diameter of the cylinder is 1, so 1 divided by 2 we get 0.5 centimeter. What about the y1? Height of the object divided by 2, h divided by 2, directly put it. So here we get h of the object 2.5 divided by 2, we get 1.25 centimeter, right? Then move to the volume v1. Volume, what's the volume formula for a cylinder? Cylinder volume formula is pi r square into h, pi r square into h. Okay, so here pi r square, here the diameter is 1, diameter is equal to 1 centimeter, the bottom it is given. So radius is nothing but 0.5 centimeter, so here 0.5 centimeter the whole square into h, 2.5 to h. So here what would be the answer for it? Here if you do the calculation, I hope you will get 1.96 centimeter cube. Okay, here it is volume not square, area is a square, but here it is a cube. Okay, just keep it in mind. Then move to the next component here, which is second one is at the top, which is a cone. So second component is a cone. For the cone, so here just place it. So cone is just like this. Okay, it's a cone x y, and from the ox, how far from it, just find it out. This is important while you are doing the calculation. So it is far from the ox with 2.5 centimeter. Okay, and then what about the height of the what about the height of the cone? 1 centimeter. And bottom this base distance which is given, that is 1 centimeter. Okay, let it be. So now it's time to plot the center of gravity. We need to find out the x bar and then y2, x2 and y2. So x2 here from OY to this particular CG distance, OY2. So component starting from just OY line, right? So now you should directly put the self-centroid formula for the cone. So here d divided by 2, in the base it is d, right? So d divided by 2, diameter is 1 centimeter. So 1 divided by 2 we get again 0.5 centimeter. Okay, y2. So y2 distance is taken from OX to this CG, this line to this. Okay, so up to this component the gap is 2.5. So add 2.5 plus the cone self CG. Okay, so this to this it is calculated, which is given in your formula h divided by 4. Okay, so now if you do the calculation, I can say 2.5 plus h is 1 divided by 4. So that hope you will get 2.75 centimeter. Okay, 2.75 centimeter. And the next volume of cone V2, second component. So here the volume of cone is 1 by 3 pi r square into h, 1 by 3 pi r square into h. So here if you put the value here as well, the diameter is 1 centimeter. It is the diameter, okay, it is the diameter. Here it is given 1 centimeter, so radius would be 0.5 centimeter. Okay, so pi 0.5 centimeter the whole square into height of the object is 1, so you will get 0.25 centimeter cube, right? This is volume 2. Now put it for that component. What's the that component? Which is a cut. Okay, hemisphere cut, and hemisphere, and it is cut. Okay, it's not our part, it's a removed section, right? So here if I draw it x, y, and this is O, hemisphere is something like this, right? And the radius of diameter of hemisphere is 1 centimeter. What would be the radius? 0.5. That we need to identify it. We know the logic. 1 centimeter diameter in the sense, and the radius will be 0.5. Okay, let it be. So x3 directly put the self-centroid formula, since it is starting from OX and OY. Okay, no issue, directly put the self-centroid formula here. And the x direction, which is x direction, the full length is diameter, so diameter, so d divided by 2. Here diameter is 1, so 1 by 2, 0.5 centimeter, right? And y bar, that means y3, here y3 formula O2 this CG, right? y3. So here for the hemisphere, the y3, here it is the entire length is radius, so put 3r divided by 8. So 3 into 0.5 divided by 8, we get 0.1875 centimeter. Okay, next volume, find out the volume. So V3 value, here hemisphere volume is half the sphere, so 2 by 3 pi r cube. Okay, 2 by 3 pi r cube. What would be the value? 2 divided by 3 pi into radius is 0.5 the whole cube. The answer will be 0.262. Just put it in your calculator and find out. So here the next step is the identifying the CG for the entire components with respect to OX and OY, which is X bar and Y bar. CG. Okay, let's identify X bar. So here the formula is very easy in terms of volume, since it is homogeneous material. Okay, v1 into x1 plus v2 into x2 minus v3 into x2. Why I put the minus sign? Here the hemisphere, the that component which is a removed section, which is not our part, this is our part, this is alone our part, this is a removed section, so we need to minus it or subtract it. So here volume 1 plus volume 2 plus volume 3. So what would be the values? v1 is 1.96 into x1, which is 0.5 plus v2 volume 2, which is 0.25 into x2 is 0.5. Okay, minus v3 value is 0.262 into 0.5, which is x3, divided by 1.96 v1 plus 0.25 v2 minus, it is minus volume 3, we need to minus it, it's a removed section, so minus v3 value is 0.262. okay, so I hope you will get here x bar as 0.5 centimeter, right. Then it is a y bar, so y bar formula is the similar fashion. If you write it x v1 in terms of y, v1 y1 plus v2 y2 minus v3 y3 divided by v1 plus v2 minus v3. So here we will get it's x bar, and here we will get v1 is 1.96 into y1 is 1.25 plus v2 0.25 into y2, which is 2.75 minus, what is the value? v3 is 0.262 into x3 0.1875. okay, divided by all the volumes 1.96 plus 0.25 minus 0.262. so we get the value for the x bar. Okay, we get the value for x bar and you put the calculation 1.59 centimeter. This is the y bar, and this is the answer for x bar. Okay, so I hope you understood how to plot the x bar and y bar when you are having the center of gravity, that means the 3D object like cone, cylinder and hemisphere or sphere, something like this. I hope you understood. Thank you so much.